All right, so the goal for writing these is you're being given the zeros. We're going to write the equation. What we did in the last unit is I gave you the equation and you had to go find all the zeros. So we're just doing that in reverse. Couple of things I have to say before we get to actually writing the equations. First, let's talk about I real quick. I is defined to be square root of -1. That's how you get a negative under the square root. If I were to square both sides of that equation, what would I squared equal? Think about that for a second. If I square that, what would I get? Good, just -1. If you square both sides of this, the squared and the square root cancel, and you just get -1. That's your link between the real and the imaginary. So I don't know if you want to like box that in, highlight it, underline it, put some stars around that. Every time you see an I squared, you're going to replace it with a -1. So you can replace something imaginary with something real, because -1 is a real number. Okay. Also, if your zeros are irrational, which means like you had a weird square root, do you know what I mean? Like a plus and minus square root of something weird, like plus and minus square root of 7 or something like that. Or complex, which means imaginary, like there's an I in it. They happen in what are called conjugate pairs. Did you do conjugate pairs in Algebra 2? It used to be part of the Algebra 2 curriculum, but it might not be anymore. You're all just kind of staring at me. Oh, forgot. Okay, or you saw it but forgot. Okay, that's fine. I'm gonna go over it. I was just checking. All it means is the opposite operation. So if you were adding, you subtract. If you were subtracting, you add. So for example, give me some numbers. All right, let's do 7 plus, give me another number. Square root of 22. You have 7 plus square root of 22. Its conjugate would be 7 minus square root of 22. That's literally all there is to that. And it comes from the plus minus, like the plus and minus that's in there. So that's an example of an irrational one. Complex, give me some more numbers. We'll just make up an example. Do -4 minus 18i. If you have -4 minus 18i, the conjugate would be -4 plus 18i. Do you guys get it? It's just, if it was plus, you do minus. If it was minus, you do plus. Okay. And you'll see what happens when we multiply them together. The idea is that stuff cancels out. That's what it does, because one's positive and one's negative. All right, so write an equation that has the following zeros. These get long, like horizontally, so maybe start all the way over at the edge of the paper. And so we're going to write out the factors. Now, if you have x equals 0, that factor would just be x. Like that, you can write x minus 0 if you want, but this is already going to be crowded enough. So probably just put x. If you have x equals 6, the factor will be x minus 6, because 6 minus 6 is 0. Do you see how we're just doing it backwards? Okay. And then for -2, you would have x plus 2, because -2 plus 2 is 0. And then what you're going to do is multiply all that together. Again, I told you it's tedious, so you're going to have a little bit of perseverance here. First, let's just leave that x out front alone, and we're going to do FOIL for this. First, outside, inside, left. So x times x is x squared. The outsides are 2x, the insides are minus 6x. So what's that going to give us? Good, -4x. And then -6 times 2 would be -12. And then your last step is distribute the x through there. So your final answer will be x cubed minus 4x squared minus 12x. Ladies and gentlemen, this is how I made your problems in the last unit. Is I decided what I wanted the answers to be, and then I multiplied them all together, and then this is the problem that I gave you. Make sense? You're just doing it backwards, okay? So let's try another one. F of x equals, now for the -1/2, you would want to have x plus 1/2, but you do not want to deal with multiplying that fraction in there. So what you want to do is multiply through by a 2, because a 2 and a 1/2 will cancel out. So if you multiply a 2 into there, what would you get? Yeah, good, 2x plus 1. So if you have a fraction, clear out the fraction first. All right, and then what would be your factor for 3? X equals 3. X minus 3. Now it says that one has a multiplicity of 2. That means it's a twin, and so you're going to write it twice. And then again, we have the tedious job of multiplying this all together, but you can do it. I believe in you. Now you can only multiply 2 of them together at once. So just like on this first problem, that X just kind of like waited patiently, we're going to have this 2X plus 1 just like wait its turn. And we're going to do FOIL for this. So it'll be X squared. And then what do the outsides and insides give us? We'll have minus 3 and minus 3. So minus 6x, negative 3 times negative 3 plus 9. All right, now you can't call this next thing FOIL because this is 3 terms. This is a trinomial. What you're going to do is distribute the 2x to everybody and then distribute the 1 to everybody. Again, it's tedious. It's a lot of distributing, but I believe in you. You can do it, all right? Distributing the 2x, that's going to give you 2x cubed minus 12x squared plus 18x. And then if you distribute the 1, well, 1's not going to change anything. So it'll just be x squared minus 6x plus 9. You get this big long string of terms. And your last step is to combine like terms. So let's see what'll go together. Nothing will go with the 2x cubed. We've got negative 12x squared plus x squared. So that's minus 11x squared. And then how many x's will we have? 12, good, plus 12x plus 9. And then that is your final answer. Also, let me draw your attention to this. Do you see how both of these problems had 3 zeros? And we ended up with a degree of 3? Like you can make sure that that matches. All right, let's try another one. Sorry, this one has like the hole in the paper here. All right, for 4, what is the factor going to be? Good, x minus 4. And then square root of 7 will be x minus square root of 7. Here's the thing. Those irrational ones, square root of 7 is irrational. It happens in a conjugate pair. So if you have x minus square root of 7, you're also going to have x plus square root of 7. Even though it doesn't say it in the problem, you need to know that it's there. All right, and then we're going to multiply it all together. So leave the x minus 4 alone. And this is what's great about conjugate pairs. Watch this. X times x will be x squared. But what happens to the outsides and the insides? They cancel because one's positive and one's negative. Hey, Ms. Cole, will that always happen with a conjugate pair? Yes. Isn't that great? Gone. All right. Now, when you multiply these, negative times positive is going to be negative. What would square root of 7 times square root of 7 give us? It'll just be 7. Square root of 7 times square root of 7 would be square root of 49, which is 7. So the root also cancels. Isn't that great? And then we're going to multiply these together. So that'll be x cubed. And I'm going to do the insides first to make it go in descending order. Is anyone else like it has to go in descending order? I have to have it in order. It'll be minus 4x squared. And then the outsides will be minus 7x. And then negative 4 times negative 7 will be 28. The outsides and insides didn't combine together that time. That's because this was just an x and this was an x squared. So they weren't like terms. They didn't go together. If you're like, hey, I didn't quite get that, we're going to do it again. What would be your first factor for this one? Plus 6. Good. X plus 6. And then for the square root of 2, you're going to have x minus square root of 2. And even though it's not written there, you're also going to have x plus square root of 2. And the joyful thing there is stuff's going to cancel out. So leave the x plus 6 alone. And when you multiply these together, you're going to get x squared. Outsides and insides cancel. They're gone. A negative times a positive will be negative. Square root of 2 times square root of 2 is 2. It would be square root of 4, which would give you 2. And then you're going to multiply those together. So that would be x cubed. And then what next? Good. Plus 6x squared. and then minus, not 4x, but 2x, good, minus 2x, and then minus 12. All right, we'll do a couple more and then I'll give you a break. X equals -1. That factor would be x plus 1. And it says that that has a multiplicity of 2. So we're going to write it twice. That's a twin. Notice the twins aren't conjugate pairs. They're both plus or both minus. So those aren't going to cancel out. And then we've got 3i. So you would have x minus 3i. But those imaginary ones, the irrational and the imaginary ones happen in conjugate pairs. So you're also going to have x plus 3i. So hey guys, look, how many factors do we have? 4. You better end up with an x to the 4th in your answer. Like the degree is going to have to match that. So here's what I would do. I would multiply these two together and multiply these two together. You can only do 2 at a time. So let's do the first 2 and then the second 2. So this will be x squared. The outsides are 1x, the insides are 1x. So together 2x, and then 1 times 1 is 1. For these two, you'll get x squared, and then the outsides and insides cancel because one's positive and one's negative. That's the nice thing about that. And when you multiply the lasts, a negative times a positive is going to be negative. I'm going to write this off to the side here. 3 times 3 is 9, and I times I would be what? Good. I squared is -1. So it's -9 times -1, it's going to be plus 9. So anytime you see an I squared, replace it with a negative. It's just going to flip-flop the sign. And then we got to multiply all this together. So here's what I would do. Distribute the x squared to everybody. And then we'll distribute the 9 to everybody. So that'll give you x to the 4th plus 2x cubed plus x squared. And then distributing the 9, that'll be 9x squared plus 18x plus 9. And then I think the only terms that will go together are these two. So everything else, you're just kind of copying it down again. But we'll have a 10x squared in the middle there. And hey guys, look, we ended up with an x to the 4th, like we said we would. I told you it was going to be a little tedious and I delivered, didn't I? But it's not hard, right? It's just, you have to multiply stuff. All right, for that square root of 3, what are our 2 factors going to be? Because we're going to have 2 factors for that x. Good, and it doesn't matter what order you write them in. One's positive and one's negative. And the same thing's going to happen for the 4i's. So you have x minus 4i, x plus 4i. So since that is 4 factors, you should end up with an x to the 4th in your answer. We're going to do these first 2, and then we're going to do the second 2. So when you do the first 2, x times x is x squared. Outsides and insides cancel. What will you get for the last terms? So these 2 together. Good, it'll just be 3 and it'll be negative, good. Minus 3. Square root of 3 times square root of 3 would be square root of 9, which is 3. All right, and then these 2, x times x is x squared. Outsides and insides cancel. And when you multiply the lasts, you will get -16i squared. 4 times 4 is 16, it's negative. I times I is I squared. What is that gonna reduce down to? Good, it'll just be plus 16. Again, the I squared is negative. -1 times -16 will be 16. All right, and then we're gonna multiply those 2 together. X squared times x squared is x to the 4th. The outsides are 16x squared. The insides are minus 3x squared. So that would give us 13x squared, and then negative 3 times 16 is negative 48. I'm going to pause the video. I want you guys to try number 7, talk to the people around you, and then I'll give you the answer. So did you have 4 factors? Good. Okay, so we should have 4. We're going to multiply the first 2 together and the second 2 together. So what did you get from the first 2? It'll be x squared and then what? Good, plus 49. This would give you, when you multiply these together, it would give you negative 49i squared. I squared is a negative, so the negatives cancel. It'll be plus 49. And then these 2 will be x squared plus, good, 4, perfect. When you multiply these together, it'll be negative 4i squared. So again, I squared is a negative, negatives cancel. So when you multiply these together, x squared times x squared will be x to the 4th. The outsides are 4x squared. The insides are 49x squared. So what is that, 53? X squared. Did you run into a problem here? 49 times 4. There's 2 ways you can think of that. I would probably in my head just do 50 times 4 and then subtract 4. Because what would 50 times 4 be? Be 200 minus 4 would be 196. So this should be your final answer. Did anybody get that, or like did that? Okay. Let's review how to multiply numbers though. Let's say you needed to do 49 times 4 and you didn't have a calculator. Do you guys remember how to do this? Okay, well, let's review it. Let's review it real quick. 9 times 4 is 36. So you write the 36, but the 3 goes on top here. And then 4 times 4 is 16. And then plus 3 would be 19. So 196. So you just multiply this to the first number and write it down. Like you carry that over, and then you multiply it to the second one and then add that. I'm gonna pause the recording and I'll make up one. All right, so number 8, we'll have f of x equals. And for x equals 2, the factor would be x minus 2. But it says with a multiplicity of 5. So it, oh, I'm sorry. Well, I can see it. Sorry, I'm sorry. There we go. So it would be x minus 2 5 times. You'd have x minus 2, x minus 2, x. Okay, so to the 5th power. But hold on, I'm going to teach you a shortcut for doing that. That's what the other half of the lesson is how you can expand these without having to do all that work. And it is called the binomial theorem. Bi means 2, like a bicycle has 2 wheels. It's how you expand a binomial. Do you see how x minus 2 is 2 terms? So it works if you have something like x minus 2 to the 5th, or x minus 2 to the 7th, or x plus 3 to the 9th. Like as long as there's 2 terms to a power, that's what this binomial theorem is for. We're going to start with Pascal's triangle. You'll have to let me know if you've seen this anywhere before. Start with 1, and then the next row is 1, 1, and then the next row is 1, 2, 1, and then you have 1, 3, 3, 1. I'll see if you guys are finding the pattern. The next one would be 1, 4, 6, 4, 1. I'm going to stop and let you look at it for a second because I want to see where the numbers are coming from, because there is a pattern. You're adding the 2 above it. So like 1 plus 1 gives you 2, 1 plus 2 gives you 3, 3 plus 3 gives you 6. So what would the next line be? It would be 1, 5, 10, another 10, 5, 1. We'll do one more. It would be 1, 6, 15, good, 20, 15, good. Okay, when I do the first one, I want you to set down your pencil and watch, because this is a pattern thing. Then I'll give you a chance to write it down, but I want you to see where it comes from. And I'm going to color code parts. After I write it out, I'm going to color code parts of it. The colors don't show up real well on here, but it'll be on the notes when I post it on school with you. So when this says x plus 2 to the fourth, you're going to use the fourth row, this one right here. I know you're probably like, Miss Cole, isn't that the fifth row? This is the 0th row. This is the first row, this is the second row, this is the third row, this is the fourth row. But just think of it this way. It's the row with the 4 in it. Okay? The fourth row is the one with the 4 in it. These are your coefficients for each term. So you're gonna have 1, 4, 6, 4, 1 is your coefficient. These are only 2-step problems. They're very short, but they get very long horizontally. So I'm gonna start all the way like over at the edge of the paper. Again, just watch, okay? We're gonna start with this 1, that's our first coefficient. We'll have x to the 4th, and then 2 to the nothing. These powers should always add up to be what's here. All right, so your next term, you're gonna use the 4. This one's gonna go down, this one's gonna go up. So it'll be x to the 3rd, and then 2 to the 1st. And then the next one, we're gonna use the 6. This one's gonna go down, this one's gonna go up. So it'll be x to the 2nd, 2 to the 2nd. The next one, we're gonna use the 4. It'll be x to the 1st, 2 to the 3rd. And then the last one, we're gonna use the 1. It'll be x to the nothing, 2 to the 4th. So let me color code for you. Here's your coefficients, 1, 4, 6, 4, 1. Do you guys see that in there? On the x's, it descends. It's 4, 3, 2, 1, 0. And then on the 2, it ascends. It's going up. 0, 1, 2, 3, 4. Do you guys see it? Okay, go ahead and write that down. And then what we're gonna do in the next step is just reduce it. Okay, and I'm gonna write the triangle on the board so that it's bigger up here and you guys can see it. Is it every time? Is it just plus? It is always plus. That's a good question. It is always plus, and you'll see in number 2 how there's a -4. You'll just put the negative with the 4. So some of the terms will end up negative, but I've found that it is easiest just to tell everybody to always put plus for simplicity's sake. Like with the remainders we did last unit, remember how I just said always put plus? I think that's easiest. So now we're going to reduce this. 2 to the 0 power. Anything to the 0 power is just 1, so you can kind of ignore that. And so this is just 1x to the 4th. Plus, all right, 2 to the 1st would be 2. 2 times 4 is 8, so 8x cubed. Plus 2 squared is 4. 4 times 6 is 24, so 24x squared. 2 cubed, do we remember what that one is? 2 cubed is what? 8, good, thank you for not saying 6. 2 cubed is 8, 8 times 4 is 32, so 32x. And then 2 to the 4th would be 16. Anything to the 0 power is 1, so you can pretty much ignore that, and then that's your answer. So it's a way you can expand these without having to do x plus 2 times x plus 2 times x plus 2 times x plus 2. You can get the answer in 2 steps. Now, anytime we do something for the first time, the first one goes slowly and it's kind of rocky, all right? Let's do the next one. And like by the time we do, that's why I put 5 examples on here instead of 1. I don't just do 1 and go, oh, see ya. You know, you have to do a few of them. We have plenty of time, right? But they do get long horizontally. So start all the way at the edge of the paper. This one's x plus 4 to the 3rd. So which line are we going to use? Yeah, this one, the one with the 3 in it. So those are your coefficients. And again, I wrote this on the board so you could look up there and see that. So those are going to be your coefficients, 1, 3, 3, 1. So it's going to be 1x to the 3rd, -4 to the nothing. So just treat it like a -4, and then you can always put plus for your term. All right, so plus, what's my next coefficient? Good, 3. This one's going to go down, this one's going to go up. So it'll be x to the 3rd, -4 to the 1st. And they should always add up to be what, oh, I had a mistake. I'm sorry. What did I do wrong? I swear I didn't do it on purpose just to test you. What did I mess up? Yeah, sorry. It should start with 3. I apologize. But do you see how I caught it? I said these should always add up to be what's here. And I was like, hey, wait, they don't add up. See, so if you're checking yourself, then you'll catch that. I'm sorry. You know, my husband asked me the other day, he's like, do you ever mess stuff up on purpose just to see if your students are paying attention? I'm like, no, I don't have to do that because I'm a human being and I mess up without having to do it on purpose. All right, we're good now. All right, plus, what's our next coefficient? Good, 3 again. And then this will be x to the first, -4 to the second. And then what's our last coefficient? 1. I would write it. I think this is very pattern driven. So I would put everything in there. It'll be x to the nothing, -4 to the third. And again, I'm going to color code for you. Here's your coefficients, 1, 3, 3, 1. For the x's, it's going to descend 3, 2, 1, 0. And then for the -4, it's going to ascend 0, 1, 2, 3. Did we get the hang of it better that time? You're going to have to do a few of them. Now we're going to reduce it. Anything to the 0 power is 1. You can just ignore that. So this is x to the third. -4 to the first would be -4 times 3 would be -12. So minus 12x squared. -4 squared would be positive 16 times 3 would be 48x. And then lastly, -4 cubed would be -64. So minus 64. So what do you notice about the signs of the terms for that? Yeah, whenever you have a subtraction, they're going to alternate positive, negative, positive, negative. So that's another way that you can check. Let's try another one. Hey guys, what coefficients are we going to use for this one since it's to the third? Yeah, same ones we just did, 1, 3, 3, 1. Okay, so it's going to be 1, and we'll have 3x to the third, 4 to the nothing. And then the next one will be 3, and then what? I'm going to start asking you guys. Good, 3x to the second, 4 first, good. All right, the next one will be 3. Good, 3x to the first, 4 to the second. And then the last coefficient's 1, it'll be 3x to the nothing, 4 to the third. These are gonna get a little large here. This is something I would probably not put on a test because the test would be non-calculated. But for the notes, I think it's fine. I always try to put like the harder questions on the notes. We do those together. All right, so let's reduce these. 3 cubed, 3 times 3 times 3. What's that gonna give us? Good, 27. So 27x cubed plus, all right, watch me point to this because there's a lot going on in this one. 4 to the first would just be 4. 3 squared would be 9. So 9 times 4 is 36 times 3. I don't have a calculator. 36 times 3. Does anyone have a calculator in their brain and can do that? 108 x squared. Again, I wouldn't put something like that on the test because you'd, well, I mean, yes, you could work it out off to the side. All right, plus. Now for this one, 4 squared would give you 16. 3 to the first would be 3. So 16 times 3 is 48. 48 times 3 is 144. And then this last one, 4. Now 4 cubed, I expect you to know. 4 cubed would be what? 64. I feel like that's more reasonable. All right, this one's to the fourth. So what coefficients are we going to use? Good, 1, 4, 6, 4, 1. So we will have 1 and then 2x to the 4th, -1 to the nothing. Again, just treat it like a -1 and then you can always put plus. All right, so the next one will be 4, 2x to the 3rd, -1 squared. I'm going to start to speed this up because I think we're getting the hang of this. 1. Oh, there, 1. Thank you. Geez, lots to look at. All right, so 6 and then 2x squared, -1 squared. And then 4, 2x to the 1st, -1 to the 3rd. And then 1, 2x to the nothing, -1 to the 4th. And if you get to the point where you don't want to write the stuff that's to the nothing, or you don't want to put these ones in here, that's okay. My suggestion though is write it, because again, this is very pattern driven. And I feel like if you leave part of the pattern out, that's just going to throw you off. So I just say write everything. They're only 2-step problems. I mean, it's not like it's a multi-step thing. Now we're going to reduce it. 2 to the 4th would be 16. So this would be 16x to the 4th. Bless you. -1 to the 1st would just be -1. So this term is just going to be negative. And again, they're going to alternate. It's going to go positive, negative, positive, negative. 2 cubed, that's 8 times 4 is 32. So minus 32x cubed. -1 squared is +1. So this one's going to be plus. Again, it's going to alternate. 2 squared is 4 times 6 is 24. So 24x squared. -1 cubed would be negative. 2 times 4 is 8, so 8x. And then the last one would just be +1. Anything to the 0 power is 1. -1 to the 4th is just 1. So that would actually just end up being 1. This one has a y in it. You're going to do the problem literally the exact same way. In fact, it's easier because you don't have to worry about taking a number to a power. It's just going to be y to the whatever. This one's to the 5th. So what coefficients are we going to use this time? 1, 5, 10, 10, 5, 1. And I'm going to say this on record on the recording. I'm never going to give you one that's higher than to the 5th. Delta math will skip those ones. Do you get what I'm saying? I don't want you to do them. If they give you one that's higher than, so you might need to skip a bunch of problems because they'll make it go all the way up to like the 9th and whatever. Don't do those. Just skip them. I'm not going to go higher than 5. Because at that point, it's like, what are you testing? Like you've gotten the pattern. We don't need to go higher than 5. All right, so this will be 1, 2x to the 5th, y to the nothing, plus 5, 2x to the 4th, y to the 1st, plus 10, 2x to the 3rd, y to the 2nd, plus another 10, 2x to the 2nd, y to the 3rd, plus, you guys tell me the next one. This is just me just talking at you at this point. It'll be 5. First, and then y to the 4th. Good. And then the last one, 2x to the nothing, y to the 5th. Good. I like barely fit it in there. Sorry, I like to do the color coding. I think that this helps. Like when you go to check it, like it helps you make sure that you didn't miss something. 2, 3, 4, 5. Okay. Now we're going to simplify it. 2 to the 5th would be 32. I know those because I sit in this room and do math problems all day long. But here, let's count it on our fingers. 2 times 2 would be what? 4 times 2 again is 8. Times 2 again is 16. Times 2 again is 32. So 2 to the 5th would be 32. Just count it on your fingers. So 32x to the 5th plus 2 to the 4th is 16 times 5 is 80. So 80x to the 4th. Oh, I forgot the y. Y to the 1st. I left the y out of the first one. How come? Why wasn't there a y in that one? Yes, to the 0, so that's nothing. Or actually, anything to the 0 power is 1, it just doesn't change anything. All right, 2 cubed is 8, times 10 is 80. So 80 x to the third, y to the second, plus 2 squared is 4, times 10 is 40. So 40x squared, y to the third. Here we just have 5 times 2 is 10, so 10x, y to the fourth. And then the last one is just y to the fifth. So what I want you guys to do is go back to the one we skipped on the front page and try that one. And I'll answer the fence. So go back and try this one. I know there's kind of not a lot of space there, just try to write little. All right, so this one would be f of x equals x to the fifth. And the signs are going to alternate from these. Whenever you're subtracting, it's going to alternate. This would be -2 to the first, which would be -2 times 5 would be -10. So minus 10x to the fourth. -2 squared is 4, times 10 is 40. So plus 40x to the third. -2 cubed would be -8 times 10 would be -80. So -80x squared. -2 to the fourth would be +16 times 5 would be 80. So plus 80x. And then -2 to the fifth would be -32. So the signs should alternate. So positive, negative, positive, negative, positive, negative. And again, I will not give you one that is higher than to the fifth. So on delta math, if you see one that's higher than to the fifth, just skip it.